Bismillahirrahmanirrahim. My name is Kainat Awasi and my roll number is 16TE83. This is the 12th lecture of digital signal processing. In this lecture, we will learn about discrete Fourier transform and fast Fourier transform. Discrete Fourier transform has one major advantage: its computational cost. The computational cost of discrete Fourier transform is very high. Like if we have n components, then we require number of additions, that is n cross n minus 1, and multiplications n cross n, that is n square. And as we know that n square is non-linear functional, so this is the main disadvantage of discrete Fourier transform. To overcome this computational cost, we move toward fast Fourier transform. What is fast Fourier transform? Let W of n is equal to e raised to power minus j 2 pi n. Then the formula for computing fast Fourier transform is x of k is summation n is 0 to n minus 1 x of n W of n into kn. We consider a unit circle. Let's say n is equal to 8. Then this circle is decomposed into 8 parts. At W of 8, 0, that is at 0 we will get 1. Similarly, at W of 8, 1, we have 0.7071 minus j of 0.7071. At W of 8, 2, we have minus j. W of 8, 3 minus 0.707 minus j of 0.707. At W of 8, 4, we have minus 1. W of 8, 5, it is the conjugate of W of 8, 1, minus 0.7071 plus j of 0.7071. At W of 8, 6, we have plus j, and similarly at W of 8, 7, we have the conjugate of W of 8, 3, that is 0.7071 plus j of 0.7071. If you know the concept of this unit circle, you know the fast Fourier transform, how to compute the fast Fourier transform. So let's consider the previous sequence. In time domain and frequency domain, you can get this sequence from my previous lecture, that is lecture 11. At time domain, we have 8 values, x of 0 to x of 7, 3, 4, 5, 6, 7. And what was that sequence? 1, minus 2, 3, 1, 2, minus 1, 2 and 1. Similarly, we computed x of k, that is frequency domain sequence, capital X of 0 to x of 7. 3, 4, 5, 6 and 7. And the values were 7, minus 1.7071 minus 0.2929j, minus 2 plus j5, minus 0.2929 plus j of 1.70719. And x of 5 is the conjugate of x of 3, x of 6 was the conjugate of x of 2. Similarly, x of 7 was the conjugate of x of 1. The number of multiplication we needed using the above sequence of discrete Fourier transform was 64 and additions were 56. Now we will see how the fast Fourier transform reduces the computational cost. First of all, we divide our sequence into 4-point discrete Fourier transform. That is, we use even and odd decomposition. This is for even decomposition. I denote it with E. And then our same sequence 4-point discrete Fourier transform into odd sequence. And I will write it as x of 0, x of 2, x of 4, and x of 6, x of 1, x of 3, x of 5, x of 7. It was 1, 3, 2, and 2, and minus 2, minus 1, minus 1, and 1. And we will compute E of 0 against x of 0, E of 1, E of 2, and E of 3, and similarly O of 0, O of 1, O of 2, and O of 3. O here denotes odd sequence and E denotes the even sequence. Using the formula x of k is equal to n is 0 to 3 x of n wkn. We know that for this sequence wkn is equal to w for 2. I will compute only one, and in the same way you can compute all. Let's say that is E of 1. Opening the summation x of 0 w for 2 of 0, you can see this value from the corresponding circle by dividing the circle into 4 parts. That is this w for 0, w for 1, w for 2, and w for 3. It is 1 plus 1 minus j minus 1 and plus j. W for 2 of 1, x of 2, w for 2 of 3 plus x of 1, 2, x of 3, w for 2 of 3. And by putting the values we will get 1, x of 0 is 1 and this is 1, 3 into plus 3 into minus j plus 2 into minus 1 plus 2 into j, and it comes out minus 1 minus j. And in the same way we will compute the other values. E of 0 is 8, E of 2 is minus 2, and E of 3 is conjugate of E of 1, that is minus 1 plus j. And of 0 is minus 1, minus 1, minus 5, and minus 1. Now we will see the computational cost in this case. Previously, we required additions and multiplications. Multiplications were 64 and additions were 56. And now we will require number of additions, that are 12 plus 12 plus 8, and multiplication are reduced to 32. These are also 32. You see that the computational cost is almost half of the above sequence. And if we want to go from fast Fourier transform to discrete Fourier transform, we can use our simplest formula, that is x of k is equal to E of n times wnk of n. I will show you for one sequence, let's say x of 1. that is E of 1 plus W8K of 1, and by putting the corresponding value you will get minus 1.7071 minus 0.2929G. Thank you very much.